many industries are leaning toward applying the machine learning concepts, the tools and the processes that are within the machine learning and artificial intelligence. Now, based on the literature review, there are multiple benefits of utilizing the machine learning and inspecting and coding the sewer defects or anomalies. Some of them would enhance and decrease some others. So it is expected that the productivity level of using the machine learning in sewer inspection will increase. And because of the reduction of the subjectivity and the errors, then the accuracy and precision will increase. And furthermore, trying to adapt new technologies and applications that will basically refine our future, refine how we are processing the different processes that we were adopting in old ages. And because of these, we are basically going to reduce the costs because of the different resources, whether they are the direct and indirect cost. We are going to enhance our delivery to our clients by the durations or the reduced durations or schedules that we promised. And definitely we are going to reduce the resources, as mentioned, whether they are related to the direct and indirect resources. And ultimately, we want to build our informed decisions based on reduced errors or minimized errors and subjectivity. So these are the main components of deploying a machine learning. So a typical arrangement of a machine learning or a typical output of a machine learning is basically having the outputs or training the machine, trying to minimize the human intervention in analyzing the defects or identifying those defects, where the bulk of the work will be based on the machine learning algorithm or the tool that we are training, depending on the different models that are available within the machine learning. And basically the tool or the model will be able to spit out the different defects that are within the frame that is being analyzed, so that we can schedule our repairs, we can cost estimate our repairs, and basically determine when we are going to intervene depending on the severities of those defects. Now, in the literature, there are some attempts to use the AI in detecting anomalies or defects in sewers, but there are some limitations, and some of these limitations are the lack of data set. It's not a matter of the number of images that I have, but it's a matter of also the variations of the features within those images. In addition to that, many of the models do focus on the defect groups, structural, operational, construction features, or so on and so forth, but not the modifiers. And this is because of the unavailable or the scarcity of the data to train the models. In addition to that, some of the annotations or some of the models are basically trained by annotated images or using annotated images by non-certified PACP. And we're mostly going to see these kind of models by that are developed within the university level or so. In addition to that, many of the models do focus on a few number of defects, which may not drive the capital plan, such as some operational defects that would not require major capital improvement plans or major capital plans. In addition to that, and because most of the clients right now in North America are behind or deploying the PACP protocol, many of the models do not basically satisfy the minimum requirements of the PACP. So it is really important when considering a model to enhance it and reach to a level where it can satisfy acceptable standard and existing practices. Now, in order to enhance the existing practices to develop a tool that can be reliable with higher accuracy, we relied on an objective. And this objective is basically developing an automated and intelligent tool. And the sub-objectives were developing a model that can classify the defects or classify the frames into defective frame versus non-defective frame from a defect perspective or sewer defect perspective, localize those defects based on their location within the frame, the clock reference, and so on and so forth, and also detecting those defects, especially when we have more than one defect in a frame. So the model that we relied on developing this automated and intelligent tool is under the umbrella of the artificial neural network. And this model has been applied in different fields and not only in the infrastructure. And this is basically an implementation of the tool. It is considered as a deep learning tool. It is composed of different layers. The main input data is basically the frames with the defects. The more defects or the more examples that we have, the more the model is going to train or get trained and learn from the experience. Now, the different layers that we have in a convolutional neural network is the convolutional and then subsampling up to getting to the fully connected layer. Now, as I mentioned, this is heavily dependent on the data set that we have. It's not only a factor of the number of images that we have, but the variations of the features within those defects or those images. The process that we relied on is basically heavily dependent on the CCTV videos that we have from the different programs. Then we ensured that those annotations are done by PACP certified staff. It ran through the QA/QC, the quality control, to make sure that the annotations are correctly done. Then we moved to the machine learning training the model in order to detect the defects. Now, the accuracy, if the accuracy was achieved and as per our expectations, then the loop will end. Otherwise, the model is going to be retrained by the NASCO certified by adjusting some annotations and making sure that the annotations are correctly done.